Hi, in this video we're going to look at a probability question that's suitable for students aiming for a grade 9 in their GCSE maths exam. So the question states that a box contains blue and red counters. There are n blue counters in the box and the ratio of blue to red is 2 to 5. 3 counters are chosen at random and are not replaced. The probability of picking 3 blue counters is 1 over 20. Show that 61n squared plus 62n minus 88 is equal to 0. So first, write out the ratio of blue to red counters, which is 2 to 5. Then, express this ratio in fraction form. To do this, note that there are 7 parts in total, of which 2 parts are blue. So the fraction of blue counters is 2/7, and the fraction that are red is 5/7. Now, we've been told that there are n blue counters in the box, but we don't yet know how many counters there are in total. But if we know that 2/7 of the counters are blue, and that there's n blue counters, we can work out an expression for how many counters there are in total. To do this, let n be equal to 2/7, which just means 2/7 of all the counters are blue. We then want to change 2/7 to a whole one, because this would represent the total number of counters. To do this, multiply both sides of the equation by 7 over 2 to give 7n over 2 is equal to 1. So therefore, 7n over 2 is an expression that represents the total number of counters. Okay, so the question states that 3 counters are removed from the box and are not replaced. This means we're dealing with a dependent probability question where the probability of taking the second and third counters depends on what was taken out of the box for the first 2 times. They've also told us that the probability of picking 3 blues is 1 out of 20, so we want to form an expression that's equal to 1 over 20. So picking the first blue is n divided by 7n over 2, because there are n blue counters in the box and 7n over 2 counters in total. Picking a second blue counter is n minus 1 divided by 7n over 2 minus 1, because 1 blue counter has been removed and was not replaced, and there's 1 less counter in total. And finally, picking a third blue counter is n minus 2 divided by 7n over 2 minus 2, because another blue counter was removed and not replaced, and 2 counters were removed from the total. Okay, so we now multiply these 3 probabilities together and make them equal to 1 over 20, as this is the probability of picking 3 blue counters. And hopefully, now that we have an equation, this should simplify to the 61n squared plus 62n minus 88 is equal to 0, as was given in the question. So first, let's simplify the first term. If we multiply both the numerator and denominator by 2, this becomes 2n divided by 7n, which then cancels to 2/7. Similarly, multiply the numerator and denominators on the second and third terms by 2, which gives 2 times n minus 1 over 7n minus 2, and 2 times n minus 2 divided by 7n minus 4, and then make these equal to 1 over 20. Next, multiply these 3 fractions to give 8 times n minus 1 times n minus 2 divided by 7 times 7n minus 2 times 7n minus 4. And this is equal to 1 over 20. And then expand both brackets to give 8 times n squared minus 3n plus 2 divided by 7 times 49n squared minus 42n plus 8, which is equal to 1 over 20. And so we have 8n squared minus 24n plus 16 divided by 343n squared minus 294n plus 56 is equal to 1 over 20. Then cross multiply to remove the fraction on the left hand side. So we have 343n squared minus 294n plus 56 is equal to 160n squared minus 480n plus 320. Now move everything to the left-hand side to give 183n squared plus 186n minus 264 is equal to 0. And finally, simplify by dividing both sides of the equation by 3 to give 61n squared plus 62n minus 88 is equal to 0. Okay, so that's how you answer a tricky probability question that's suitable for students aiming for a grade 9. If you found this video useful, please give it a thumbs up and subscribe to my channel where you'll find more videos for GCSE maths. Thanks for watching.